going to do is define what each parallel and perpendicular exactly mean. So what do parallel lines look like? All right, they don't touch, right? What keeps them from intersecting? What do they have? The same what? Slope. Okay, so we're going to put that down first. So they have the same slope, but do they have the same y-intercept? No, because then they'd be the same line, right? So same slope and different y-intercept. Like you guys said, these will be two lines that never intersect. And then the last thing we need to make note of is the symbol that we use to denote parallel. So our symbol or notation for parallel lines is this right here. All right, perpendicular. What are perpendicular lines? They intersect at what? Out of the middle. A 90-degree angle. They intersect at a 90-degree angle. What makes them intersect at a 90-degree angle? So over here, my slope was the same. What's true about my slopes here? They're exact opposites, right? So if this one was 1/2, this one would be flipped over, so it becomes 2, and it'd have to be negative, right? You change the sign and you flip it. Okay, so here our slopes are opposite reciprocals. Also important to note, we said that over here the y-intercepts have to be different. They don't necessarily have to be different here. That could actually be the point where they're intersecting, right? So here your y-intercept can't be the same, but it doesn't have to be. So the y-intercept can be the same. Like we said, these are going to intersect at a 90-degree angle. And then lastly, our symbol or our notation for perpendicular. It's like an upside down capital T. Okay, so now we've kind of refreshed our memory on what those mean, what it is we're looking for. Now they want us to graph a set of parallel lines here and a set of perpendicular lines on that second graph. All right, so let's say our original function is y equals 1/2 x plus 2. All right, so I'm going to go ahead and graph this line. I would first put down the y-intercept, which is at 2, good, and has a slope of 1/2, so that means we're going up 1/2. All right. So if I have a line parallel to this one, what do I already know about its slope? Same. So still 1/2 x, but I know the y-intercept can't be the same, right? So it can't be 2, but it can be literally anything else. So maybe this one has a y-intercept at -3. So I put my y-intercept at -3, and then using my slope, plot the remainder of the points. So it's something like this. Okay. All right, now switching gears, talking about perpendicular graphs, we're going to have that same original line segment, that y equals 1/2 x plus 2. I'm going to go ahead and graph the original line, so it looks exactly like the first one we graphed over there. All right, but for the perpendicular line, I already know what the slope should be. What is it? -2. Good. So -2x. And my y-intercept could be +2, but it doesn't have to be. It could be any number. So here, we're going to be restricted. It can't be the same. Here it could be, but it doesn't necessarily have to be. Maybe this one also has a y-intercept at -3, like that second line over there. So if I put myself a point at -3, and my slope is -2, what does that mean I'm going to do to plot my remaining points? Where will I go? Down 2, and then right 1. So we have their intersection point right here, and it should look like those are intersecting at that 90-degree angle. They're exact opposites of one another, so they do intersect at that 90-degree angle. Okay, so now we're just going to talk about a couple of things that we notice when comparing these two graphs. All right, so if we were comparing what we have up here to a new slope of m equals -3/2. Now I've got the equation y equals -3/2 x, and maybe it has a new y-intercept. Okay, let's say it's +5. Okay, if I was to create another line that's parallel to this one with a slope of -3/2, what would the slope of the other line be if it's parallel? -3/2. So it would also be parallel if it's -3/2. All right, for this line, the one that we just wrote down, what was the y-intercept? 5. For a line that's parallel to this one, what could its y-intercept be? Yeah. Anything else? Right. Anything except 5. Right. So here we could say that B could be any real number. Remember, this is our symbol for real numbers. It's that capital R with the double line. Except 5. Okay. So if I were to compare that over here to some line that I want to be perpendicular, so still got that same equation, -3/2 x plus 5. So currently, my slope is -3/2. If I want a line perpendicular to that, what would the slope be? +2/3. Good. All right, and currently over here, my B value is 5. For a line perpendicular to that, what could B be? Anything, no restrictions, right? So here I can say B could be any real number, no restriction this time. Okay. Now we're going to compare our slope-intercept form and our point-slope form. We are going to be given, let's say, a line that we want to be parallel to that -3/2 slope, and I want it to go through the point 3, 5. All right, so with this information, I don't know what b is right now, right? So I can't write it in slope-intercept form. But how could I write it? Point slope. Okay, what would that look like? Uh-huh. Nice. Okay, but if they were insisting that the answer be written in slope-intercept form, I could turn this into slope-intercept form, right? All I would need to do is simplify what we currently have written. So if I was going to simplify this equation, what do you guys think we would do first? Right, distribute that slope into the parentheses. So I would do that -3/2 times x, which would give us -3/2 x, good. And -3/2 times -3. So remember, whenever you're multiplying fractions, you multiply numerators, right? You could put this over 1 if you want to make it a fraction. What's -3 times -3? Positive 9 over 2 times 1, which is 2. All right. Okay, so now what should we do? Add 5 to the other side. Okay, so I'd have y equals -3/2 x plus 9/2 plus 5. However, if I want to add 5 to 9/2, which is what its like term would be, I would have to turn it into a fraction, right? So what would 5 be as a fraction with a common denominator 2? 5/1 would be a fraction. If I wanted to have the common denominator 2, what would it be? 10/2. Good. We can too. We can. But I do also want us to remember how to deal with the fractions, especially because our slope has to be a fraction, right? Because if we're going to graph it, we got to have the number on top and the number on bottom. So it's just good practice to be able to keep it in fraction form. So we'd have y equals that -3/2 x, and what is 9/2 plus 10/2? 19/2. Now that's not to say that if you did have to go graph this, you may not know what 19/2 would be as a y-intercept. You could divide it by 2, turn it into a decimal, and then you'd know exactly where to put it on that y-axis. Okay. All right. So same thing, but now for our perpendicular line. So if it is perpendicular, we know that the slope is what? So -3/2. 2/3, good. And again, we want it to go through this point, 3, 5. So right now I can't have it in that slope-intercept form, but we can write it in point slope. And what would that look like?
Y minus 5.
Good. Uh-huh. Good.
X minus 4.
Very good. Good job.
Yes.
All right. And then if I want to turn it into slope-intercept form, just like before, I now need to simplify, right? So the first thing you guys said that we should do before is distribute that 2/3. So what's 2/3 times x? Good. And 2/3 times -3. Remember, we multiply numerators and denominators. -2, very good. Then what should we do? Add 5. So we end up with y is equal to 2/3 x plus what? 3. Very good. All right. Okay. Flip it over onto the back. Okay. here it says to write the slope of the equation below, then write the parallel slope, and then write the perpendicular slope. You should have 3 answers for each part. So let me do the first one with you to show you exactly what that means. What is the slope on A? 2. Okay, then it wants you to give what the parallel slope would be, which would be 2. And then it wants you to also give the perpendicular slope, which would be negative 1/2. Good. That's all it wants you to do. So you guys do the next 3 there. Flip it over. So 2 is the same as 2 over 1, right? Flip it over and then change the sign. All right, so you guys do B, C, and D, and then we'll check our answers here in just a moment. Okay, can somebody tell me what our slope was for B? Good. Which meant the parallel slope was also negative 3. And the perpendicular slope was 1/3. Good. All right, on C, what was our slope? 1/2. So parallel slope was also, and perpendicular? Negative 2. All right, for D, what was my slope? Negative 2 over 3. So parallel would be? And perpendicular? Positive 3 over 2. Good. Okay. For these next couple here, it says you may want to refer to the flow chart from the front, but you are going to write the equation of a line parallel to this one and has a y-intercept of negative 4. Okay? So that one, they were pretty straightforward, giving you all the pieces. Okay? They want it in slope-intercept form. Here, they give you another line, but this time they just give you a point that it passes through. Okay? They want both of these written in slope-intercept form. So you may have to do a little solving like we did on those last 2. Okay? I'll give you just a second to work those 2 out, and then we'll share our answers. Check those answers. On number 2, they said they wanted a line parallel to the one given. So what did the slope have to be? 2. So my equation would be y equals 2x minus 4. Right. All right, this next one was just a little bit different because they did tell us what they wanted the slope to be. Since it's parallel, it's going to be what? The same slope, so negative 2/3. But this time they didn't tell us the y-intercept. We were given a point. So I have to write it which way before I can put it in slope-intercept form. Point slope, right. So what would that look like? Y what? Okay, equals nice. All right, so y minus 0 is really just y, right? We don't have to worry about that. And then what do I do with that negative 2/3? Distribute. And what do we get? Minus what? 4 over 3. Good. All right. Okay, number 4. This time they said they want a line that's perpendicular to the one given. So what's our slope going to be? Reciprocal, right? So that would be positive 1/2. Okay? Has the same y-intercept, so what's my equation going to be? 1/2 x plus 3. Good. All right, last one here. This one says, write the equation that's perpendicular to the one on the graph and passes through the point 1, negative 1. Okay, so first of all, the graph, what is its current slope? Negative 1/2. So that would mean the perpendicular slope would be positive 2. Good. And we know that it's going to go through this point, right? So if it goes through that point, I can do what we did on number 3 and write it in point slope form and then simplify, right? All right, so let's see here. I would have for my equation y what? Plus 1, good, equals, good, times You could graph it like this because we do know now that it goes through the point 1, -1, which means it's got a point right here. And we know that our slope is 2. So I can go ahead and start plotting points. Or if you prefer to graph it in slope-intercept, you can do like we did before. You would just distribute and subtract. Either way is fine. Now you know you have your y-intercept at -3, which we would have come across plotting the slope of 2 anyway. Alright, and these are exact opposite lines. So we should have that 90-degree angle at the intersection points.